Hi everybody, Mrs. Bowen here, and we're going to take a look at Learning Target 5.1. I can solve systems of equations by graphing. So we do see graphs on our page, but what does this mean, systems of equations? What this means is that we're no longer looking at one equation, or in this case, one line that we're graphing. We're now looking at two. So two equations here forms a system. And when you graph two separate lines and we're trying to solve the system, we're looking at where these two lines intersect. So in step one, we're going to have to graph each line. Step one, graph each line, which graphing lines is going to be review of a previous learning target. And then in step two, we'll find the point of intersection. Find the point of intersection. And keep in mind that points are x, comma, y. So our final answer is going to be a point or an ordered pair x, comma, y. And this point is the solution to the system, meaning the x value and the y value. When you plug in the x value and the y value, it makes the equation true. So it is true for both equations, which makes the system of equations true. So our directions say to solve each system by graphing. And so in example one, I have two separate lines that I will need to graph. So I'll start out with the first line. I'll do this one in purple. And notice that this equation is already in slope-intercept form. Y equals mx plus b. And so I can use slope-intercept form to help me graph. So my b is always the number we have at the end, plus or minus a number. So my y-intercept is -6, which means it's going to intercept or cross my y-axis at -6. So I can go on my y-axis and I can put a point at -6. Then I can consider my slope. My m, my slope is always the number we see in front of x, so it's 1/4. And keep in mind, slope is always rise over run. So starting at my y-intercept, I can go up 1, right 4, up 1, right 4, and put a point. I can go up 1, right 4, and put a point. When we are graphing systems of equations, meaning we have more than one equation that we have to graph, it's important that you fit as many points as you possibly can onto your graph. So I would like to put some more points going in the other direction. If you don't put as many points as you can on your graph, it is very hard to see where the lines intersect because you need to know the exact point that they will intersect at. So if I wanted to put some points going in the other direction, instead of going up 1, right 4, the other way I could think of this slope is going down 1 and backwards or left 4. And again, this is still a positive slope because negative divided by negative gives us a positive. So starting at my y-intercept, I could use slope written this way to go down 1, left 4. Again, I could go down 1, left 4. And now I have points going all the way across my graph. So I can connect my points with a straight line. And I have one line graphed. Now I need to do the same thing for my second line. I'll do this one in a blue. And so my b here is 1. So that means I need to go to my y-axis and I need to put a point at 1. Then I need to consider my slope. My slope is 2, or we could say 2 over 1, so positive slope. So I can go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. But again, I would like to put some more points going in the other direction. So I can represent this positive slope of 2, or 2 over 1, by going in the other direction, and I can do -2 over -1. Or starting at my y-intercept again, my y-intercept here at 1, I can go down 2, left 1, down 2, left 1, down 2, left 1. And then we can see here's where they're intersecting. So I have nice, neat lines graphed here. And my point of intersection is right here where the two lines cross. And so for my final answer, I can say that my point of intersection is this point, x comma y. So my x value is at -4. And my y value is down at -7. And this would be my final answer, that the solution to this system of equations, or the solution -4 comma -7, makes this system true. Meaning, if I plug in x is -4 and y is -7, this will be true. It will indeed be a true statement. It will be equal. And I could also plug this point -4 comma -7 into my top equation, and I would get a true statement. So this point is the solution, and it's also the point of intersection here for both of these lines. Let's look at example 2. And the issue with example 2 is that my equations are not in slope-intercept form. So I'm going to need to do some work. So for my first equation, I'm actually going to rewrite it up here. I have x minus 6y equals -54. And I'd like to get that in slope-intercept form. So if I'm trying to get y by itself or isolate y, I'd like to move this positive 1x to the other side. And I can do that by subtracting x from both sides. And I'll get -6y equals. I have to be careful. I cannot do -54 minus x and combine those. -54 is a constant term and -x is a variable term. So I have to leave them separate. And I'm going to write my x term first. So notice I left my signs the same. It's still a -x and it's still a -54. But I'm putting my x term first so that it looks like it's in slope-intercept form. Now I have one last thing to do to get y by itself. This is -6 times y. So my last step here would be to divide by -6. And I have to divide by -6 on every term. So then I'll get y equals, here I have -x divided by -6. This is like saying -1x. -1 divided by -6 turns to a positive 16x. -54 divided by -6 gives me a positive 9. So here's my equation in slope-intercept form that I need to graph. So using this equation, I can say that my b is 9, or my y-intercept is 9. I can go to my y-axis, and I can put a point at 9. And then the slope that I'm going to use is 1/6. So I can go up 1 and over 6. Could also go in the other direction, right? I could go down 1, left 6, or backward 6. The only thing you need to be careful of is that this looks like a positive slope, right? If it's a positive 1/6 for our slope, that means when we look at our line here and we scan our graph from left to right, it has to look like I'm going uphill. And yes, it does look like a positive slope. So I did one line. This is a system though, so I have a second line. I'm going to do this scratch work over here in the margin because I need to get this equation in slope-intercept form. So I have 7x plus 6y equals 6. I can first subtract 7x over to the other side. And I'll get 6y equals -7x plus 6. Again, I'm not combining variables and constants. My last step here, divide by 6. Notice I'm doing very similar steps that I just did to get my other equation in slope-intercept form. And I'll get y equals -7 over 6x. And I'm doing 6 divided by 6, which gives me 1. So here's my equation that I need to graph in slope-intercept form. And I can make a note that my b is 1. So I can go to my y-axis and put a point at 1. My slope here is negative. When your slope is negative, you can put the negative sign in the top So I could put it with the 7, or I could put it in the bottom with the 6, but I can't do both, right? If this is a negative slope, then there can only be one negative sign. So if I use slope going in this, written this way, then I would start at my y-intercept of 1, and I would go down 7 and right 6 and put a point. And if I'm using slope written this way, I would go up 7, left 6. So I would go up 7, left 6. And right there we can see that's going to be our point of intersection. So here's where my two lines intersect. So that means that our solution is this ordered pair. So my x value is how much you go left or right. So this point is left 6, so -6, comma. And then my y value is how much you go up or down. This point's up 8. So I have -6, comma 8 as my ordered pair. And that would be my final answer. That's my solution to this system of equations. 2 more examples. Example 3. These equations are both in slope-intercept form, so they'll be quicker to graph. So in example 3, for my first equation, my b is at -2. So I can go to my y-axis and put a point at -2. My m, my slope is 4/7. So I can go up 4, right 7. I can also represent this positive slope by doing the double negative part. Negative divided by negative gives me a positive. So the other way I could represent this slope, starting again from my y-intercept of -2, I could go down 4, left 7. Down 4, left 7. It's forming a straight line. Need to also graph my second equation. My b here is up at 9. Let's go to my y-axis, put a point at 9. My slope here is 4/7, or we could represent it as -4/7. And maybe you're noticing something here. We've got the same slope, 4/7. So to finish this line here, I'm up at my y-intercept at 9, and I could go down 4, left 7. And then my next point here, I could go up 4, and we can kind of eyeball. They'd be going like this. And we're noticing here, these lines are parallel, right? And if we just look at the equations, we've learned about parallel lines. They have the same slope, 4/7, but they have different y-intercepts or different starting positions on the graph. So these are parallel lines. Do these ever intersect? No. So since there's no point of intersection, there's going to be no solution. We won't have a point of intersection. There's no way we could write an ordered pair, x comma y, that is the point of intersection and that is the solution, because these two parallel lines will never intersect. All right, we have one last example, example 4. And on example 4, my equations are not in slope-intercept form. So I'm going to have to get them in slope-intercept form first. Let's see, this top equation actually is going to be pretty quick to get it to be in y equals mx plus b, because if you notice, the -3y is on a side by itself. And I could rewrite this. I think a lot of students prefer to see y written on the left. So all I'm going to do right here is flip the two sides. So I have -3y equals 21 minus 3x. So on one side of the equal sign, I still have -3y. And on the other side of the equal sign, I still have 21 minus 3x. All I did was just switch what was on the left and right side. I didn't move it, right? I did not use inverse operations to move anything to the other side. I'm just flipping it. I'm keeping signs the same. So what was on the left of the equal sign and what was on the right of the equal sign, I just switched them. Now maybe it's a little bit more clear that we almost have y by itself. There's only one step we need to do here. We need to get rid of this -3 times y And we can do that by dividing by -3. And then we'll get y equals 21 divided by -3 gives me -7. -3x divided by -3. Well, -3 divided by -3 is just positive, so that's a positive 1x, or we could just say positive x. The only thing I don't like about this equation is that when I write y equals mx plus b, I like my x term to come next, so I'm going to rewrite it y equals x minus 7. Hope you're okay with that. Notice I still kept it a positive x. I still kept it -7. I just switched the order so that it looks like my slope-intercept form. Now I can graph this equation because it's in slope-intercept form. So my b is at -7. So I can go to my y-axis and put a point at -7. Then I can look at my slope, which is again the number we see in front of x, and here it's just 1, or we could say 1/1. I like to write slope like this because then it helps me to see rise over run. So 1/1. So starting at my y-intercept of -7, I'll go up 1/1, up 1/1, up 1/1. I can continue on. I could also go down 1, left 1, down 1, left 1. And I can connect these points with a line. I have my second equation to graph. I'll graph that one once I get it in slope-intercept form. So I'll write it over here in the margin. I have x minus y equals 7. I'm trying to get y by itself, so I need to move this x to the other side. So I can subtract x from both sides, and I'll get -y equals. You cannot do 7 minus x and combine those because we have a constant term and a variable term. So I'll leave it as -x plus 7. Notice I'm choosing to put the x term first and the constant term second. I almost have y by itself, but I need to get rid of this negative in front of y, or that's like saying -1 times y. So my last step here would be to divide by -1, and I'll get y equals -1x divided by -1 turns to positive. 7 divided by -1, we'll turn that to -7. And actually, what do we see here? They're the same equation. Y equals x minus 7. Let's still go to graph it, see what happens. So I need to put my y-intercept down at -7. And then for my slope, I'm noticing it's a slope of 1 or 1/1. So I'd go up 1/1, up 1/1. And we're actually going to end up graphing the same line on top of itself. And so when you have the same line and you're trying to find the point of intersection, wouldn't it intersect everywhere? It would intersect at this point, at this point, at this point. And what about all the little points in between, right? Every spot that you look at, and keep in mind this line continues forever in both directions. No matter where you look on this line, you can think of it as it's intersecting with itself because it is itself. So that means that we're not just going to have one point of intersection here that we can write as an ordered pair. Instead, we're going to have something called infinite solutions, meaning any solution will work because we have the same line. So any of these points here, and when I say any solution will work, it has to be one of the solutions that fall on this line. So what I mean by that, if we look at let's say this ordered pair right here, when x is 3 and y is -4, that would be a solution. If we look here at this point right here, when x is 0 and y is -7, that would be a solution. So any of the infinitely many points that fall on this line, they would be a solution. So we can say there are infinite solutions. All right, so we did 4 examples, and now if you flip to the back side, you have 2 u-tris. You'll notice the second u-tri is actually easier because your equations are already in slope-intercept form. And the first u-tri, I left you some space here. You're going to have to get these equations in slope-intercept form before you can graph them. So at this time, go ahead, pause the video and see what you come up with. Let's see how you did. So for my first equation, here's my work getting it into slope-intercept form. I got y equals 1 over 4x plus 5, which means my y-intercept is at 5. And for my slope, I can go up 1, right 4, up 1, right 4. I could also, for my y-intercept, go down 1, left 4. For my second equation, here's my work getting that equation into slope-intercept form. I got y equals 3 over 2x minus 5. So my y-intercept was at negative 5. And for my slope, I could go up 3, right 2, up 3, right 2, up 3, right 2. And then we notice our two lines do intersect at this point. And so I need to write this point as an ordered pair. And so my final answer would be this point of intersection, which is the point x comma y, or 8 comma 7. So my final answer, my solution to this system of equations would be 8 comma 7. The second U-try was easier because my equations were already in slope-intercept form. So I could graph both of my equations, and hopefully you noticed that these two equations had the same slope of 1/3. And so when I graph them, they have different y-intercepts. One is starting up at 7 and one is starting down at negative 9. And because they have the same slope and different y-intercepts, they are parallel lines. And so they're never going to intersect. So there's no way I could come up with an ordered pair that is the solution. And so for that reason, there is no solution. To finish up our notes, let's summarize what we've learned. So at the bottom of our notes, it says systems of equations have blank of solutions. And we learned there are 3 types of solutions. And that's why we've got 3 graphs here. So our first graph here is showing that we have 2 lines graphed and that they are intersecting here at a point. And so in this case, we would get one solution, and I'll say we have one solution, but let's remember that that one solution is always an ordered pair, right? X comma y. And this happens, this is our, we could call it point of intersection. One solution, we write that solution as x comma y, and it's a point of intersection between the 2 lines. The second type of solution, here we have 2 parallel lines that will never intersect. And so here we have no solution. We can make a note that that is because these are parallel lines. Parallel lines will never have a solution because they never have an intersection point. And then in this last case, if you look very closely, you can see 2 arrows here on the end. This is actually a line graphed on top of itself, or it's the same line here. And so in this case, we have infinite solutions because it's the same line. When we end up graphing, if you're graphing the same line on top of itself, that means that you could pick any point on that line and that point would be a solution. So as we continue to work on systems of equations, we'll see these 3 types of solutions where you can get an answer. You write an ordered pair, x comma y. You would write no solution, or you would write infinite solutions.